This is Chapter 3, Section 6 notes. Today we're going to be talking about compound inequalities. We have two types of compound inequalities. We have an AND compound. So it looks like this. One large inequality, 3 is less than x is less than 17. So x is in the middle between 3 and 17. So when I graph this on a number line, I'll have something like 3, and a bunch of things, and then all the way to 17. Because there aren't any lines under these, they'll both be open dots. And then all I have to do is connect these two dots, because all of these numbers in between here will work for an x number. Okay? So my x number, my number that I don't know exactly what it is, can be any number between 3 and 17. That's an AND inequality. An OR inequality actually has the word OR in it. So x is less than 12, or x is greater than or equal to 20. So same type of example, if I have a number line, start with 12, end at 20. At the 12, because there's no line underneath this one, it'd be an open dot. And my x would be going less than, or to the left. And then this next one, it would be a closed dot at 20 and going to the right. Okay, so see how there's a gap here between 12 and 20? That means any number that's smaller than 12 will work for an x value. Any number that's bigger than 20 will work for an x value, but anything between 12 and 20 will not work as a solution. Okay, so there's a gap here, and for the AND, they're connected. So what does that look like in an actual problem? So it says, write and graph a compound inequality that represents the phrase. For A, it's all real numbers that are greater than -2 and less than 6. So what we're going to do, because we see the AND sign, is we're going to put the x in the middle, and you're going to make sure you have a less than and a less than sign. And so this should be -2, because that's the smallest number, is less than x is less than 6, which is the larger number. So it always goes in that order. Small number, x in the middle, larger number. Okay? So part B says all real numbers that are less than 0, or, so I'm going to have an or in the middle, greater than or equal to 5. So I'm going to write out this x is less than 0, so that's pretty easy to write out, or x is greater than or equal to 5. So I use my greater than or equal to sign and then 5. Okay, so solving compound inequalities. So let's start with an AND problem. So we have -3 is less than or equal to m minus 4 is less than 1, -1. Graph the solution. So if I cover up these two ends, notice in the middle I have m minus 4. My whole object of this is to get that variable, that m, by itself. So if I have m minus 4, to get it by itself, I'm going to add 4. Now, because I have two sides now, I have to add 4 in 3 parts. I have to add 4 to the -3, I have to add 4 to the -4 here to cancel it out, and I have to add 4 to the -1 on this end. So I start over here. -3 plus 4 should give me 1. M should be the only thing left in the middle, and then -1 plus 4 is 3. So this is my final answer, because m is already by itself. So 1 is less than or equal to m is less than 3. So then I graph it. So I make my number line. I'm going to have a closed dot at 1, because there's a line underneath here, and an open dot where 3 is, and then I just connect those two dots because the m is in the middle. Problem number 3, we're actually going to skip this problem, so you can cross that one out. Problem number 4 is solving a compound inequality. So what are the solutions of 3t plus 2 is less than negative 7, or negative 4t plus 5 is less than 1. Graph the solutions. Because this is an OR problem, I'm going to treat them like two completely separate problems. So I'm going to solve this first inequality first. So I'm going to subtract 2 from both sides. Then I'm going to, so then I get 3t is greater than or equal to negative 9. Then I divide by 3, so I get t is less than 3. T is less than negative 3. So that's just one inequality solved. Then I go to the next inequality and I do the exact same thing. Solve this inequality for t. So I'm going to start by subtracting 5 from both sides. That'll cross this out, giving me with negative 4t is less than negative 4. Divide each side by negative 4, and because I'm dividing by a negative number, I have to flip the symbol. So I have to flip that inequality sign. So my final answer for this one will be t is greater than 1. So now I'm just off to graphing these two. I graph them on the same line, but they are separate. There should be a gap in between. So I start with t is less than negative 3. That's an open dot at negative 3, and it goes to the left. The next one is t is greater than 1. That starts at 1 with an open dot, and it goes to the right.